Hello and welcome back to Minute Micro Macro. We're doing our AP series and we're looking at the 2024 Set 2 paper today. I'm going to start by reading through the question. Now, Arzai Pharma has a patent, that'll be important to us later, a legal barrier to entry on a newly developed eye treatment that cures common eye problems. Arzai Pharma is currently earning positive economic profit and is producing the profit maximizing quantity of eye treatments. Draw a correctly labeled graph for Arzai Pharma showing each of the following. They want the profit maximizing quantity, the profit maximizing price, the average total cost curve, and the area representing the consumer surplus. So let's have a go at that. First thing I'm going to do is draw my axes. I'm going to draw cost, revenue, and price on my y-axis and output or quantity on my x-axis. Then we know that they have a patent, which is a barrier to entry. If they have a barrier to entry, we're not talking about a perfectly competitive market. We've got a downward sloping demand curve. I'm going to get red for average revenue. Now they have a patent, which means that there are considerable barriers to entry. So I'm going to have a very steep demand curve to show that it's inelastic for the most part. So I'm going to label that average revenue. We know that marginal revenue is twice as steep as average revenue. So I'm going to try and aim for the midpoint. And I'm actually going to draw it through to the negative. I'm going to go over that with my ruler because that doesn't look straight enough to me. You should be drawing all your lines with a ruler. I just skip it sometimes on the whiteboard. We know that they will have an average cost curve. Now I try and aim for the minimum point of my average cost curve to be in between the two lines because it makes for a neater diagram. And that's my average total cost. And then we know that our marginal cost will cut through our average total cost at its minimum point. And that's my marginal cost curve. So the first thing they asked for was the profit maximizing quantity. We know the profit maximizing quantity is set where MC equals MR. So on my diagram, it's the point where my orange line and my blue line intersect. And from there, I draw a dotted line down and they want us to label that Q star. Then they want the profit maximizing price. To find the profit maximizing price, we go from our quantity up until we hit average revenue. In this case, it's the red line, and then across to my cost price axis, and we're labeling that P star. Next, the average total cost curve consistent with a positive economic profit. Well, this is consistent with a positive economic profit because at this quantity, my cost is here and my price is here. And so the area that would be represented by this rectangle that I'm tracing would be our economic profit. We've done I, and finally IV, the area representing consumer surplus. Consumer surplus is the difference between the price the consumer was willing and able to pay, which we know is the demand curve shown by average revenue, and the price they were paying set by the firm. That is this triangle here. So that is all of part A complete. Part B. Suppose that Arzai Pharma want to charge a price that maximizes total revenue rather than its profit. So we're maximizing total revenue. On your graph from part A, show the revenue maximizing quantity labeled QR. Then at quantity QR, identified by part BI, is the demand for eye treatments elastic, inelastic, or unit elastic. So the revenue maximizing quantity is where MR equals 0. My marginal revenue equals 0 at this point here, and so we're going to label that QR. This is because, I'm going to draw a little side note here. If we think about our demand or our average revenue and how that translates over to total revenue, our average revenue is used to calculate total revenue because at each quantity, we know the price they would set. The total revenue is the area in that rectangle. And we can see initially, as my output or quantity increases, the total revenue rectangle is getting larger. The area is greater. It's getting bigger again, getting bigger again. So we know initially my total revenue is increasing, but we will reach a point where continuing to increase my quantity will lead to a smaller and smaller rectangle. And so my total revenue starts to decrease. Now, when we calculate marginal revenue, it's the additional revenue for each one unit across we go. So I'm going to go across one and up, across one and up, across one and up, and across one and up. And we can see each time I'm increasing by a smaller and smaller amount. So it's positive, but it's at a decreasing rate until we get to a point where my marginal revenue is 0. I'm no longer increasing. This correlates to my marginal revenue that I draw in these diagrams. It's positive but decreasing until it hits 0. And then we can see here, for every one I go across, my marginal revenue is negative because my total revenue goes down. So if this was brand new to you, you need to go back and revise that. Okay. That will help us understand our II. At the revenue maximizing quantity, is it going to be elastic, inelastic, or inelastic? Well, here, when price falls, my total revenue is increasing, which means that I have an elastic portion of my average revenue curve. Here, my total revenue is decreasing as price falls. So I have an inelastic portion of my average revenue curve, which lines up with where MR is positive at the elastic portion and MR is negative for the inelastic portion. The easy, quick way to remember this in the exam is Old MacDonald had a farm, E-I-E-I-O. At this point, which is where QR is, so we transition from the elastic to the inelastic portion. So here we are unit elastic. My total revenue is not changing at that point. Okay, part C. Suppose now that Arzai farmer engages in perfect price discrimination. So perfect price discrimination is when consumers pay the maximum they were willing and able to pay for their good, and the firm is able to charge each different consumer a different price. That is first degree price discrimination, or sometimes called perfect price discrimination. What's going to happen to our area of consumer surplus? Show the lowest price that Arzai farmer would charge if they could get away with perfect price discrimination, and what would happen to the consumer surplus. So the lowest price they could charge is going to be labeled P2. Well, they would keep charging all the way until they were no longer making profit on that last unit. And so they're going to consume where MC equals AR. So that's this point here, and we're labeling that P2. And then what would happen to consumer surplus? It would disappear to 0. There would be no difference between the price that the firm charges each individual person and the price they're willing and able to pay. So there would be no area. Our price is not a single price for every consumer. D. Suppose instead that Arzai's farmer patent expires. Will the demand for Arzai's farmer treatment become more elastic, become less elastic, or not change? Well, if their patent expires, they're losing their barrier to entry. If they're losing their barrier to entry, it means more firms are going to be able to enter the market, going to increase the competition. We're increasing the amount of competition, there'll be more substitutes for the consumers to buy. If we're increasing the number of substitutes the consumers are going to buy, we're going to make the demand curve more elastic because they can switch to a cheaper alternative. If they're able to switch, it means that the demand can be more responsive to price changes. So part D, suppose instead that Arzai farmer's patent expires. Will the demand for farmer treatment become more elastic, less elastic, or not change? It will become more elastic. Question 2. The table provided shows the short-run production function for Lowen Feline, a profit-maximizing firm that produces cat food. Lowen Feline, I'm assuming I'm saying that right, sells as many bags of cat food as it wants at a market price of $10 per bag. That is an important piece of information. And hires as many workers as it wants at a market wage of $18. That is also key information. So we're hiring from a perfectly competitive labour market. Low and feline fixed cost is $90. Calculate the average fixed cost if low and feline hires 6 workers. Show your work. This is a standard question, but it feels like a trap because I can imagine a lot of people will go in and say, oh, okay, well, 90 divided by 6. That is not what you're doing. We don't ever work out average fixed cost by dividing by the number of workers. We work out average fixed cost by taking our fixed cost and dividing it by the output, the number of products you're producing. So if I have a fixed cost of 90, average fixed cost, and we're hiring 6 workers, let's go here. You can see that I'm producing 30 bags of cat food, and $90 divided by 30 bags of cat food is going to equal $3. Happy days. Question A is done. Part B. Assume labour is the only variable input to low and feline. Calculate the marginal cost if low and feline increases output from 27 to 30 units. Show your work. So I'm going to use the whiteboard here. They want us to give them the marginal cost. And we know that marginal cost is equal to the change in total cost divided by the change in output. Well, our total cost includes our fixed cost and our variable cost. Our fixed cost isn't changing, it's fixed. So that's the same as the change in variable cost divided by my change in output. We were told the only variable cost is the $18 per worker. Now, if I go from 27 bags of cat food to 30 bags of cat food, I'm going from 5 workers to 6 workers. So I'm increasing my variable cost by 18. And the change in output is the change in number of cat food bags. That's an increase of 3 bags. And so my marginal cost is going to be $6. Question C. With the hiring of which worker do diminishing marginal returns begin? Explain using numbers. Well, what are diminishing marginal returns? It's when each additional unit of input produces less additional output. This is our input and this is our output. I'm going to transition to a larger graph so you can see more clearly. So with each additional unit of input, my additional unit of output decreases. So essentially, we're looking at our marginal physical product, the MPP. So I'm going to write that on here. My MPP. So if I move from 0 workers to 1 worker, I make an additional 5 units of cat food. If I move from 1 worker to 2 workers, I make an additional 7 units. If I move from 2 workers to 3 workers, I'll then make an additional 6 units. I'm going to fill this in quickly. 5, 4, 3, 2, 1, and actually starts going negative. So when does it start decreasing? Well, we're increasing from 1 worker to 2 workers. My MPP is increasing. But then from 2 workers to 3 workers, my MPP starts falling. Now, although the total quantity is increasing, it's increasing at a decreasing rate, which is what we're looking for. And so the number of workers is going to be 3. Part D. Determine the profit maximizing number of workers low and feline will hire using marginal analysis. Key part here, profit maximizing number of workers, and they want marginal analysis. So we're going to go back to our chart. We've got MPP. We know that firms will hire when their MRP is equal to their marginal cost of labor. The MRP is the marginal revenue product. We calculate the MRP by taking the MPP, marginal physical product, and timesing it by our marginal revenue. Well, we've worked out our MPP, but where on earth is the marginal revenue? They actually already told us. Our marginal revenue is $10 per bag. So MPP times by 10. So gives us our MRP. So we've got $50, $70, $60, 50, 40, 30, 20, 10, and negative 10. And we want to keep going until we reach a point where our MRP is equal to our marginal cost of labour, which is the wage. The wage at every level is $18. So if I hire that one extra worker, it costs me as a firm $18. And by hiring that extra worker, they produce $50 more revenue for the firm. Sounds like a good deal? We'll hire them. Now, if we're looking for the next worker, that second worker, hiring them costs me $18. And by hiring them, they're producing, not necessarily on their own, but by adding them to the team, they're producing $70 more revenue. So it's a good idea to hire them. And you can see that makes sense to hire the third person, the fourth, the fifth, sixth, even the seventh additional worker costs me $18. They're generating $20 in revenue, makes sense to hire them. However, we look at the eighth person. If it costs me $18 to hire them, and by hiring them, they only create an additional revenue of $10, it does not make sense. So I'm going to hire 7 workers using marginal analysis. Okay. E. In the long run, rival company Gatto Food increases its production from 40 units. Its total costs increase from $600 to $900. Over the output range of 40 to 50 units, is Gatto Food experiencing economies of scale, diseconomies of scale, or constant returns to scale? Explain using numbers. If we're thinking about long-run average cost, because we're talking about economies of scale, we know that during economies of scale, our long-run average costs fall as output increases. If we have constant returns, it is horizontal. And if we move into diseconomies of scale, our long-run average costs increase as output increases. So we've got economies of scale, constant return, diseconomies of scale. We're looking at our long-run average cost, but we don't know which parts they're in. Well, what they have told us is that the initial average cost was $600, and that made them 40 units. So their long-run average cost at that point was $15. They move on to say that their costs increase to $900 when they're producing 50 units. So the long-run average cost there is 18. Well, if their average cost has gone from 15 to 18, it's increasing. So we must be over in this part of the graph. So we are in diseconomies of scale. Okay, question 3. Backpacks are produced in a perfectly competitive market that has no externalities. The provided graph shows the market supply and demand curves for backpacks in the country of Jammu. A. Calculate the total economic surplus at the market equilibrium. Show your work. So we're looking for the economic surplus, that's the consumer surplus plus the producer surplus, at the market equilibrium. I'm going to use my color coding so that everything looks familiar again. Demand is down and it's red. Supply goes to the sky and it is blue. And we can see the market equilibrium price is where supply and demand intersect. And so it would be a price of $90 and the producers would make 16 backpacks and the consumers would demand 16 backpacks. We know that the consumer surplus is the difference between the price they were willing and able to pay and the price the market cleared at. And so this red triangle would be my consumer surplus. We know that producer surplus is the difference between the price producers were willing and able to accept for their goods and the price the market cleared at. And so the producer surplus is this triangle here. And so if we want the total economic surplus, we just want to find the area of this triangle. We know the area of a triangle is base times height divided by 2. If you tilt your head to the side, you can think about this being the base of the triangle so that this can be our perpendicular height of the triangle. So the base is $150 minus $30. The height of the triangle is times by 16. Divide that by 2, and we know that that is $960. Part B. To decrease the price of backpacks for students, the government of Jammu has decided to set a ceiling price of $60 per backpack. Compare to the market equilibrium. Will the quantity of backpacks purchased increase, decrease, or not change as a result of the price ceiling? So price ceiling is a price we can't go above. We're comparing that to the market equilibrium. They were going to set it at $60. So if our new price is set at $60, we can see we've created a disequilibrium. The market will not clear. Supply and demand do not intersect at this price. The amount that producers would be willing and able to supply at the price of $60 is only 8, whereas the number that the consumers will demand will be 24. So we'll have created an artificial shortage, and we can see that the quantity has decreased from 16 down to 8. So it will decrease from 16 to 8. Part C. We're going to read it and we're going to move on to a blown up larger graph. Suppose instead the government of Jambo provides a per unit subsidy to the sellers of backpacks. So to the sellers, we're thinking about supply. Identify the price paid by consumers per backpack after the per unit subsidy is implemented. Calculate the total cost of the subsidy to the government. And does the per unit subsidy cause dead weight loss to decrease, remain the same compared to the market equilibrium in part A? Explain. Okay, here's a larger version of the graph. We were operating at an equilibrium of 16 units for $90. Now the government's going to provide a per unit subsidy of $30 to the sellers. So my supply is going to increase, and by $30, it's going to be an increase in supply. So we're going to shift it out to the right, but the way we're going to measure it is looking at price. Every single point moves down 30. We're now going to cut through the origin of the graph, and you'll see that every point on the supply curve has moved down by $30. I'm going to call this supply 2, so I keep track of my graph. We know that demand is downward sloping. I can see my new equilibrium will be at 20 units, £75. $75. Get this down. So new equilibrium is shown using our dotted lines. And part A said identify the price paid by consumers per backpack. So the price paid per consumer is going to be $75. That's part I done. Part II. Calculate the total cost of the subsidy to the government. Well, the subsidy per unit is $30. We said that was a parallel shift. The government is going to provide it for all units sold. We said that they were going to sell 20 backpacks. So 30 times by 20 is going to be $600. We can represent that on a graph with our rectangle. The area of 30 times 20 is 600. Part I. Does the per unit subsidy cause dead weight loss to increase, decrease, or remain the same compared to the market equilibrium? Well, at the market equilibrium, we were being allocatively efficient. Our price was equal to the marginal cost, which is shown by supply, and there was no dead weight loss. We've now diverged from the equilibrium point, and we've generated this new equilibrium. At this new equilibrium, we have dead weight loss, shown here. It cost the government 20 times $30 to give this subsidy. The producers saw a benefit and an increase in producer surplus of this area. The consumers saw the price fall. They were paying $90, they're now paying $75. And so their increase in consumer surplus is this red area. Notice how there is a cost to the government that is not benefiting either consumers or producers. And that triangle is our dead weight loss. And that means our dead weight loss has increased from 0. And they do not ask us to calculate it, but you could work out the area of this triangle if you were asked to. Well done, you've got to the end of the paper. Work out how you've done. You can go onto the AP College Board website to get the exact mark scheme, but hopefully I've helped you understand what we're doing today. Thank you. Thank you.